Now that we've gotten all the kind of generalities about parametric equations out of the way, we can talk about derivatives of parametric curves. If you have a pair of parametric equations, remember that x and y are functions of t. So you can differentiate those equations, but what you're getting is the rate of change of x with respect to t. So that would be x prime of t, and then of course you get the rate of change of y with respect to t, or y prime of t. If we actually need slope of the curve, the rate of change of y with respect to x, then we can do this by taking dy over dt and dividing by dx over dt. So the derivative of the y equation divided by the derivative of the x equation will give you the slope of the curve. Now if you're thinking about, you're also going to see questions about where tangent lines to parametric curves are horizontal. Remember, that's going to happen where the slope of the curve is 0, and where this fraction is equal to 0 is going to be when the denominator is equal to 0 and the numerator doesn't. If you're looking at where tangent lines are vertical, vertical lines have undefined tangents, so that's going to be where the denominator, where x prime of t is equal to 0. So you will, get your equation for y prime and your equation for x prime, put them together to get the slope of the curve. If you want to find the points on the curve where the tangent line is horizontal, you start by solving this equation, which is going to give you values of t, and then you figure out what x and y correspond to those values of t. Same deal for when we're looking for vertical tangent lines, points where the tangent line is vertical. You'll solve the equation here for t and then plug in that particular value of t in your x and your y equations. And I'll leave the working examples to you because that's pretty straightforward.